Hello and welcome, dear students, professionals, and learners, to the interesting topic of dissolution. This topic is biorelevant dissolution testing, and always dissolution is a very important topic in the pharmaceutical field. So, some basic terms are there which are required to be understood before starting the actual topic. In vitro testing means it is the testing which is done outside the living body, or it is like study in the test tube. Then in vivo, this testing is done inside the living body. Then simulation, this is imitative representation, or it is like mimicry. Its meaning is to mimic. Then the three important definitions of biorelevant dissolution method, discriminatory dissolution method, and the QC release dissolution method is there. So many times it is asked that what is the difference between the biorelevant dissolution method, discriminatory method, and the QC release method. So biorelevant dissolution method is the dissolution method or condition which use the biorelevant medias or biorelevant conditions to mimic the GIT behavior. That's why dissolution testing or dissolution method done by simulating the in vivo environment of human GIT to predict drug formulation behavior in vivo. Then coming to discriminatory dissolution method. Dissolution method or testing condition which is capable of detecting the significant changes in the formulation composition, manufacturing process, storage, or any other which can affect the product quality and in vivo behavior. So this is discriminatory method. Then discriminatory power. So it is the ability of the dissolution testing condition to detect significant changes in the formulation which can affect the product quality and in vivo behavior. So these two conditions should be there in the dissolution method so that the dissolution method can detect the significant changes. Then coming to the QC release dissolution method. This method is used in routine QC testing to release the batch in the market. So nowadays regulatory authorities are asking for your QC release dissolution method to be discriminatory method. This is why, because the QC release method is used in the manufacturing plant to release the batch in the market, and if it is not a discriminatory and if it is not having the discriminatory power, then there is a chance that all the batches will pass the dissolution specification. That's why discriminatory power should be there to the QC dissolution method, and justification is also asked for the final QC release method to prove the discriminatory power. Now if you think, can your discriminatory dissolution method be a biorelevant method, or your biorelevant method may be a discriminatory dissolution method, or a discriminatory dissolution method may be a QC release method? So the answer to this is yes. Some of the QC release methods may be giving good discrimination, and that is a requirement also. And the discriminatory dissolution method may or may not give you the biorelevant dissolution method properties. The difference between these two is only biorelevant dissolution method use the dissolution testing conditions which mimic the in vivo environment of the human GIT. Like it use the biorelevant dissolution medias, whereas discriminatory method and QC release method may not use the biorelevant medias. Then we have to understand the fasted and fed conditions. What are fasted and fed conditions? And what is the importance of these conditions? See, food can affect the bioavailability of the drug, and also it can influence the bioequivalence between test and reference product. Food may interact with the formulation or drug, and due to food the gastric emptying may be delayed. That's why food can have a positive or negative impact on the bioavailability and bioequivalence. Also, food may may not have a good impact on the formulation performance. Meal composition has impact on BA and B. High fat meal, low fat meal are used in the bioequivalence studies to see the significant difference between test and reference formulation. And bioequivalence studies are performed in fasted and fed state for the same reason. That's why the impact of food needs to be studied. Then coming to the biorelevant dissolution and the difference between QC method, discriminatory method and the biorelevant dissolution method. What are the differences and what are the similarities? In QC release method or discriminatory method, testing condition may or may not mimic the in vivo GIT conditions. But when you are performing biorelevant dissolution, we are testing the product with the dissolution condition that are designed to mimic the in vivo GIT conditions, and mainly the media. Then here in QC release method, media are like water or buffered solutions. In QC release method, we use 0.1 normal HCl and other concentration of hydrochloric acid. Then buffered solutions like pH 4.5 acetate buffer, pH 7.5 acetate phosphate buffer and other buffers. But in biorelevant dissolution, the medias are used which can mimic the fasted or fed state of the gastric and intestinal area. So those medias are fasted gastric, fed gastric, then fasted intestinal and fed intestinal. So in biorelevant dissolution method, the medias are biorelevant. Then QC release method may not provide the biorelevant predictive dissolution, whereas biorelevant dissolution method provides the biorelevant predictive dissolution data. QC release testing may be a discriminatory dissolution testing, whereas the biorelevant dissolution method may not be the QC method because the medias are different from the QC method. And biorelevant dissolution method is used to predict the bioperformance of the formulation during the development phase. Before going to the pilot or pivotal B studies, and also for in the QC release method or discrimination method, the testing conditions we take mainly the media volume, pH, apparatus and the RPM. So we have to be very vigilant while checking the biorelevant dissolution. Mainly the basket apparatus and paddle apparatus are used in the biorelevant dissolution testing. Basket apparatus one may mimic the condition of stomach, and apparatus 2, that is paddle apparatus, may mimic the conditions of intestine. Because the turbulence is more in apparatus 2 compared to apparatus 1, and which refers to or which reflects the movement of stomach and the movement of intestine. So these two very important parameters are there, like apparatus 1 and 2 can be used and selected as per the formulation design and the other factors. So every time this will not be the same. The RPM or speed is the second important parameter. General speed of basket like 50 to 100 RPM is taken, and pedal also 50 to 100 RPM is taken. Low speed also can be studied. These are required to mimic the GI motility conditions. Why? Because GI motility conditions are to be simulated for biorelevant dissolution. Then media and media volume. There are simulated gastric fluid media and simulated intestinal fluid media, which can be used for the biorelevant dissolution testing. And the typical volume of 500 ml to 1000 ml can be taken, and also the other volumes can be taken to mimic the in vivo conditions, and these depend on the formulation behavior. These are not the final volumes. Based on the formulation understanding, this volume can be changed. Then coming to the biorelevant medias, mainly the two biorelevant medias are used, that are simulated gastric fluid media and simulated intestinal fluid media. Now simulated colonic fluid is also available. These are available in the fasted and fed state. So mainly for the fasted study, fasted media is used, and for fed study, fed state media are used. Biorelevant dissolution medias, as the GI environment is complex and it is hard to understand that, because there are different parameters, like different pH is there, enzyme concentration is there, presence of bile salt is there, and the motility factors. These all factors affect the biorelevant dissolution. Biorelevant medias mimic the GI media composition to get the more biorelevant dissolution data. That's why these medias are used. Then what are the pH of these medias? Like in QC release media, we take pH of 4.5, 6.8, 7.5 and many more. So we have to check the pH also. We should know what is the pH. So fasted state simulated gastric fluid, it is referred as FASSGF. It is 1.6 pH. Then fed state simulated gastric fluid is referred as FESSGF. It is having pH of 3, 4.5 or 6 based on the GI motility and the position in the stomach. Then FASSIF, it is having pH of 6.5, FESSIF with pH of 5. So these are the main medias used in the biorelevant dissolution, and you can say that the pH varies from 1.6 to 6.5. Then simulated colonic fluids are there. These are used for modified formulations, mainly for colon delivery, and as per the formulation design, these might be the delayed release formulations. So for them, For delayed release formulations, these simulated colonic fluids can be used as the biorelevant media. Then what is the composition of this media? In QC release media, the buffers are used. Here some different composition is taken to mimic the GI conditions. So FASSGF contains taurocolate, which is a bile salt, phospholipid and sodium salt, that is NaCl, to mimic the fasted state dosing. Then similarly, fed state gastric fluid contains fats, carbohydrates, dietary fibers, bile salts to mimic the fed state condition of the GI, mainly the stomach. Similarly, simulated intestinal fluid contains taurocolate, phospholipids, sodium salt and the phosphate. So here in FASSGF, phosphate is not there, and in intestinal fluid phosphate is there. Then coming to the fed state simulated intestinal fluid with pH 5, taurocolate, bile salt, phospholipid, sodium salt and acetic acid to mimic the fed state. Then coming to the factors affecting biorelevant dissolution. So many factors are there which affect the biorelevant dissolutions and the biorelevant dissolution data, which are the factors which have positive negative impact on the dissolution. So out of that, one is API or drug, the solubility, permeability or precipitation, pH dependency for solubility and degradation in the GIT. These are the most important parameters of drug which affect the biorelevant dissolutions data. Like then formulation design, that may be immediate release, modified release, delayed release, composition and the mechanism of release. These are the important parameters of formulation which have great impact on biorelevant dissolutions. Then dissolution method, dissolution conditions used for study. These have a great impact. Then manufacturing method, whether you are making your product with direct compression, wet granulation, fluid bed processing, whether you are using a specialized coating or you are using a solubility enhancement, if any. So whatever the manufacturing method is there or solubility enhancement technique is there or you are using a higher polymer content, all these factors will impact the dissolution. Then biorelevant dissolution importance. See, we cannot do the biorelevant dissolution testing or testing condition as QC release testing condition. Then what is the importance? So with biorelevant dissolution, formulations like immediate release, modified release, delayed release formulation can be tested during the optimization stage or to have the understanding of in vivo behavior of the formulation. Then these conditions provide a good simulation of in vivo. Why? Because these biorelevant media mimic the composition of stomach and the intestine. That's why they are able to provide good simulation. Information of solubility and dissolution characteristics of the API and formulation can be studied with biorelevant dissolution method. Then formulation optimization and to check potential difference in fasted and fed state media before B studies. So during optimization of formulation, these media can be used to have a forecasting of the in vivo condition. Then forecasting of food effects on the dissolution and pharmacokinetic profiles of the formulation. This is very important to have understanding of the food effect on the formulation. Then optimizing the dosing conditions. That means the drug to be dosed in fasted or fed state. That information can be made available by using the biorelevant dissolution media or testing condition. So in summary, the biorelevant medias and condition are to be studied on the product and based on the understanding and the knowledge. And these conditions may provide a very good information on the product behavior in vivo. So I think you might have got a good understanding of the biorelevant dissolution media. Then what are the differences between biorelevant method, discriminatory method and QC method? Then what is the importance of the biorelevant dissolution and the media and their composition with the pH, and how the in vitro dissolution testing apparatus and these things can be used to make the biorelevant condition. So thanks for watching this video. Please do like, share and comment. Thank you.